So we are proceeding with another question of probability, and this is the year 2025. That's happened to Advanced Mathematics Paper 2 in the Advanced Certificate of Secondary Education. And normally, according to the format, this is question number 1. Now, for this year, it contains only two cases, now with the 2 parts each. So starting with case A, let's start with case A. Here we are told a function is defined as f of x equals to 3 over 26x squared. Now, show that this function is a probability density function of a random variable x for the interval 1 to 3 inclusively. So here we need to use the properties for the probability density function. That's one of the properties is the area under the curve. It is supposed to be equals to 1. And lucky enough, we are provided with these intervals. So we can say for a probability density function, this one, f of x equals to 3 over 26x squared, to exist in the interval 1 to 3 inclusively, then we can say now this probability from 1 is less equal to this random variable should be equals to 1. Or we say area under the curve. Area under the curve should be equals to 1. So now, how do we deal with it? So we say prob of a is less equal to x or equal to b equals to integration for this probability of x, then now with respect to x, but from 1 to 3, or we say from this a to b. So this one has to be 1. So we consider it as area under the curve. Now here, this now is probability density function, the PDF. That's we are going to insert here because now it's belong to probability distribution. And now the intervals a to b, that is from 1 to 3. So we can say now the probability of 1 is less equal to x less equal to 3 equals to integration from 1 to 3. Then now the PDF we have 3 over 26 x squared now with respect to x. So we need to prove this equals to 1. If it will result 1, now we can say this function now is a probability density function according to this property. So we try to integrate here now. So we take out the constant. Now we'll have 3 over 26 integral of x squared with respect to x from 1 to 3. So we'll have 3 over 26. Here becomes x cubic according to the power rule of integration. So here over 3, now from 1 to 3. So when we simplify, these 3 and 3 cancel out, we remain with x cubic over 26. Now the interval from 1 to 3. So here we evaluate the values of the interval. We take the value of the higher limit of the higher value, we minus the value of the lower number. So we can say it becomes 3 cubic over 26. Now we minus 1 cubic over 26. So here we'll have 27, because 3 times 3 times 3, we end up getting 27 over 26. We minus 1 cubic is 1 over 26. So here we know the LCM, the same denominator. So we subtract the numerator part. So 27, we minus 1. So we end up getting 26 over 26, which is equals to 1. So after obtaining this one, that now we can comment and reach a conclusion that this function here is a probability density function, provided x is a random variable for the interval 1 to 3 inclusively. So we can say, therefore, the function that is 3 over 26 x squared is a probability density function under the interval 1 to 3 inclusively. Now let's see part 2 of case A. Part 2 now, let me rub. Now part 2, here is Roman 2. Find the mean and the standard deviation of x. Remember x, we were told earlier, is a random variable. For the interval given in part A. So we are told to find the mean. So the details, that's, so here mean, x bar, this one is required, and the standard deviation, deviation is required. Provided x is a random variable. It's a random variable. So now we can refer, for example, mean. This as arithmetic mean is the same as say now the expectation of x. In the concept of probability distribution, mean normally we term it as expectation of x. So that's normal arithmetic mean. It's the expectation of x. Now this one is given as integral because we are dealing with continuous data and not discrete. If it was discrete, it means we could use the sigma notation, sum. But here, probability density function, it involves continuous data. So we say we use now integration. Now from 1 to 3, so here you'll have x, then p of x, then now dx. So that is how now we can use that formula to find the mean. So from here, because the formula of expectation, we know earlier that it is the summation of x then p of x. Now, because we are dealing with continuous data in probability density function, this changes to integration. So that's how it's become this way. So now, here it's integration from 1 to 3, that is x. Now this p of x is a probability density function that we had. It is 3 over 26 x squared now dx. So integration from 1 to 3. Now here we can simplify and get now 3x cubic over 26 now dx. So if we integrate here, we take out this out, the constant numbers. Now when integrating x cubic, so we are going to have x power 4 over 4. Then now the limit from 1 to 3. So from here, if we try to multiply 26 and 4, with the help of scientific calculator, 26 times 4, we end up getting 104. So that is 3x raised to 4 over 104. Now, yeah, from 1 to 3 limits. So now we evaluate the value of the limit. So here will be 3 now, 3, then 3 raised to 4, then over 108 minus, here if we put 1, it remains 3 over 108. So what exactly do we have now? So 3 power 5, because here the base is 3. It means it's a matter of adding exponent because we are multiplying the same base. So 3 power 5, now we divide by 108. Now here, we can just say 3 power 5. So we end up getting 243. Yes, over 108. Now we minus 3 over 108. So if that to be the case, it means now the expectation of x, which is mean now. So the same denominator, it means 243 minus 3, we get 240 over 108. So if we try to divide now, 240 divided by 108, we end up getting that expectation of x equals to 2.2 occurring, which is approximately 2.2. Because here we're not told to live in how many decimal places, so we can try to live as 2.2. So that's case C, case 1. But now, how about standard deviation? Now, the standard deviation, the standard deviation is given by the square roots of the variance of x. And we know that the variance of x is given by the expectation now of x squared. Then now we minus uh, uh, e square of x. So that is how we find the standard deviation. So we need to know variance first, then we square root that answer for variance. So maybe I can start finding the variance of x for a random variable x, this one. Then now subtracting e square of x. So this e of x we know, this one, but e of x squared we don't know. Maybe we can find this. So here e of x squared is less more to say integral. We use the same limit now. Here is x squared now times that PDF, probability density function. So here becomes integral 1 to 3 x squared times the probability density function is 3 over 26. So 3 over 26, then x squared now with respect to x. So here, if we proceed, we end up getting, here becomes 3 over 26, x raised to 4. Then now dx. If we take out this, so here we're going to have x power 5 over 5. Then now from 1 to 3. So it has to be like that. So now 26 times 5, with the help of scientific calculator, what exactly do we get? 26 times 5. It is 130. So here we'll have 3x power 5 over 130, then 1, 2, 3. So now we can just introduce the limit. So here it will be 3, then now 3 power 5 over 130 minus, here it is 1, so we'll have getting 3 over 130. So what exactly do we have now? So here will be 3 power 6, 3 power 6, that is less more to 729 over 130 minus 3 over 130. So because of the same denominator, we subtract the numerator part. So 729 minus 3, we get 726. Then here over 130. So expectation of x squared now equals to 726 over 130. So that one, you can say 726 when we divide by 130 equals to 5.5846. Now, no problem because we are proceeding using it. We don't approximate earlier now because that will be too much approximation when we are looking for standard deviation. So after getting this now, we come to subtract this one, expectation of x square. And the very fortunate we calculated earlier. So now we can say the variance now, this variance of x equals to expectation of x square, that is 726 over 130, now minus expectation of x bracket square. So this is 2.2, now we put the square. So what exactly do we have here? So bracket 726. Now we minus 2.2 square. So here we are going to get 0.74. Maybe we fix to 4 decimal places. So that will be the variance of x. Then now, the standard deviation, we know it's a square root of the variance of x. So here it's a square root of 0.7446. So what exactly do we have now? Square root of answer. So here we're going to obtain 0.8629 and so forth. So the standard deviation now is approximate to 0.86 here. So that is now will be the standard deviation. So up to that point, We are through with part A. Now let's move for part B. Let's now move for part B. So part B there we are told the mean weight and standard deviation for 2,500 students at Kibarimu Primary School is recorded in 1989 were 35 kilogram and 6.3 kilogram respectively. Assuming that their weights are normally distributed, now determine the probability that a student picked at random will weigh more than 32 kilograms. So this is the case of normal distribution. And the Roman 2, the number of overweight students at this school, if an overweight is considered for all the students weighing above 55 kilograms. So that is the matter of probability distribution in terms of the what? Z-score concept. So here we will be looking areas under the curve that's in connection with probabilities. But the values of these random variable x that were distributed normally have to be transformed to z-score, have to be transformed to the standard values. So maybe let's see how we can approach it. So now case B, the weight and standard deviation, the mean. So we can say mu, here is the details. So mu is provided equals to 35 kilogram, and the standard deviation, that is 6.3. Assuming that their weights are normally distributed, it means that x is normally distributed, we know, with parameter mu and the standard deviation. X is random variable, normally distributed. So the probability that, now we are told to determine in Roman 1, probability that a student picked at random will weigh more than 32. So that x will be more than 32 kilograms. And now in Roman 2, the number of overweight students at this school, if an overweight is considered for all the students weighing above that one. So here, it means we need to know the probability for overweight above 55 kilograms. So this is also needed, required. But also at this part, we need to know the number of events. If provided the number of sample space, it means the total number of students were 2,500. So these are the cases that are involved here. And now solution, we are supposed to transform these random variable x to the standard value, I mean the score, because they are already in normal distribution. And for this case, we are not applying the continuity correction because here we are not transforming binomial to normal. So it's already normal distribution case. So we just use the value as they are. Now from the concept of z-score, which is x minus the mu, the mean over the standard deviation. So now we can say for xc equals to 32, how about the z-score? So this score will be 32. Now we minus the mu, that is 35, then over the standard deviation that we have 6.3. So this equals to what? Now from our calculator here, here will be -3 divided by 6.3. So here becomes negative 0.476. Yeah, 6. maybe 2 decimal places, four decimal places, just approximate. And now, uh, if that to be the case, for that x equals to 55, so what will be the value of z? So z now equals to 55 minus 35, the mu over the standard deviation. So this is less more to what? 55 minus 35, it is 20. 20 now divide by 6.3. That will be 3.1746. Yes, fixed it to 4 decimal places. So if that to be the case, then now, starting with this, the probability that the student picked at random will weigh more than 32 kilograms. So for this case, this probability of x greater than 32, it means it's the same as say probability of z now greater than 30, than that what? 32. We say after changing now this 32, we have obtained negative 0.4762. So it will be the same. Will be the same. So for we to calculate this, it means probability it is always area under the normal distribution curve, which normally look like a belly shaped graph. So here, so now this value, maybe it is here. Here is negative 0.4, maybe 762. So greater, it means now we are going, it is tailly to the right, tailly to the right. So if that's happened, this is our z-score now. So it means probability of this one when z now is greater than negative 0.4762, this is the same as say 1 minus the probability of this when it is less, when this is less than negative 0.4762. So here we are going for normal distributional table, or because we have this non-programmable scientific calculator, we can go and calculate this cumulative probability by taking 1 minus this probability of z less to that value. So it's like saying we go for mod, then we add this SD or the statistical ribbon, then shift we go for distribution. Now we choose P because P concerned with the cumulative probability to the left side and the Q the cumulative probability to the right side. So we use P now. P for negative 0.47, then is 62. So this become, so here it becomes 1 minus 0.31697. So now, if we take 1 minus answer, so here we are going to get 0.68, then 3, 0. So that's now will be the probability for this z greater than this much, which is now approximately 68 percent the area under the curve, as you can see shoot to the right. So that will be now the answer. So we can say the probability that a student picked at random will weigh more than 32 kg, so will be this one. So this will be the probability. Yes. And now in case 2, here in part B, we are told to find the number of overweight students at this school if an overweight is considered for all the students weighing above 55 kilograms. It means we need to know the probability, cumulative probability when this random variable x is greater than 55, or the z-score for this x55, which is this one, 3.176, probability of it. After getting now, we come to the normal probability formula. So we get the number of event, because that is what now is required here. So in Roman 2, now here probability of x greater than 55 is the same as say probability for the z-score greater than 3.17 then 446. So the same thing that we are doing here. So here it will be 1 minus probability of z now less than 3.1746. So if we are looking for this now, so here it is going to be, if we take 1 minus now shift distribution 1, then it is 3.1746. 1746 bracket. So that becomes 0.000 then 75. So that is approximate now to say 0.008. Yeah, it can be like that. Now, but we have been asked now, we can say now from, we are told to find the number of overweight students. That probability of this now, z greater than this 1746, it will be equals to the number of events. It means now the number of students we divide by the number of sample space, which now we know it is here. The number of students, that the mean weight and standard deviation for 2,500 students. It means here the total number of students, it was this one. So if we multiply now, so if we multiply now, answer when we multiply with 2 this much, so we are going to get here 1.875 approximately, because here we are talking about number of students. They cannot be expressed in decimals, so we need to approximate. So it is approximated to the nearest whole number, that will be 2. So now we can conclude and say 2 students. The number of overweight students were 2. So we can say here now, therefore, the number of overweight students was 2. And up to that point, now we have answered that question number 1 in the year 2025 that appeared in Advanced Mathematics paper 2. Thank you very much.